Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Identify the dipole moments conceptually. CCl4, carbon tetrachloride tetrahedral geometry with 4 identical CCl bonds. All bond dipoles cancel symmetrically. Net dipole moment is equal to 0d, CHCl3, chloroform 3 CCl bonds and 1 CH bond in tetrahedral geometry. The 3 CCl dipoles do not fully cancel because the CH bond is different. The resultant dipole is moderate. Experimentally, CHCl3 has mu 1.87d CH to Cl2 dichloromethane to CCl bonds and to CH bonds in tetrahedral geometry. The 2 CCl bonds add vectorially, giving a net dipole. Experimentally, CH to Cl2 has mu 1.60d, weight actually CH to Cl2 1.60d and CHCl3 1.87d, so CHCl3 CH to Cl2. Actually, let me reconsider, CH to Cl2 mu 1.60d, CHCl3 mu 1.87d. So CHCl3 CH to Cl2 CIS-CHCl is equal to CHCl, CIS 1, 2 dichlorothene. The 2 CCl bond dipoles are on the same side and add constructively. Experimentally, CIS 1, 2 dichlorothene has mu 1.89d, which is larger than CHCl3. Moving on to the next step. CIS-CHCl is equal to CHCl, 1.89d, CHCl3, 1.87d, CH to Cl2, 1.60d, CCl4, 0d. This matches option, CCIS-CHCl is equal to CHCl CH to Cl to CHCl3 CCl4. And for the final step. A. Incorrectly places CCl4 second and omits CIS isomer properly. B. Has CH to Cl, not CH to Cl2, and wrong ordering. D. Incorrectly places CHCl3 first and uses CHCl2, not a standard compound in this context, ignoring the large dipole of CIS-CHCl is equal to CHCl. Therefore, the correct answer is C. Therefore, the correct answer is option C.